Hello and welcome. Today we're going to be looking at our second writing informative passage. This one is called A Work in Progress, the Periodic Table. As always, we're going to be going through all 11 questions of this passage. We're going to read through this entire passage so that you get an idea on how to approach these writing informative passages and are ready to ace the SAT writing and language section. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. A work in progress, the periodic table. How long does it take to write a chemistry textbook? And we're saying which choice most effectively introduces the main topic of the passage. Well, the main topic of the passage is the periodic table, as you can see from the title. So we're going to talk about the periodic table, right? Let's look through the passage. Talking about uh, the, talking about this conception. So it's created here, right? They're talking about the basic principles of it. To attempt, right? I'm just looking at this, talking about the periodic table, talking about where it came from, right? So if we're talking about where the periodic table came from, that's going to seem like answer choice D. Where did the modern periodic table come from? All right, move on to the next question. Now ubiquitous sight in chemistry classrooms, the conception of this orderly arrangement of the elements was due to 19th century Russian chemist Dmitry Mendeleev while he was writing a textbook on general chemistry. So this is a modifier, right? So what is the ubiquitous site in chemistry classrooms? It's the periodic table. So the first part after this has to be the periodic table, right? Or something that is the periodic table, just another way to say the periodic table. Because this part right here, the modifier, and it has to modify this, the first word that comes here, which is going to have to be the periodic table. All right, so we can see that this seems to be choice D, this orderly arrangement of the elements. That is the periodic table. That's basically saying the periodic table. It's not the chemist himself. It's not Dmitry Mendeleev. It's not the conception of the orderly arrangement. That doesn't work. All right. Then we move on to the next question. The basic principle of Mendeleev's periodic order elements have remained the same even as it has grown in size. So it says have right here, right? Have is a plural. So the basic principle, this has to be plural because it's a subject here and the verb is here and the subject and verb have to agree in the tense and the number. So they already both are present tense, but this has to be plural. The plural of principle is principles. It's still this idea of principle as in like a value that's held and not principles, like in terms of what, like the leader of a school or something, right? And we can move on to the next question. All right, this key development in the history of science still defines our contemporary understanding of matter in today's time. All right, so this is going to be a repetition question, a precision and concision question. So we already have the of matter part right here. So contemporary understanding of matter in today's times is just a repeat of contemporary. They mean the same thing. We can cross out the ones that say in today's times. And then we have contemporary understanding of matter and contemporary understanding and how we think about matter. Well, it's talking about the of, right? It's saying of matter, so we have to say of matter, and that's our answer. We can also see that this is the shortest answer that works. Always look to the shortest answer that still works. That's going to be your answer. All right. Question 5. Like many scientific breakthroughs, Mendeleev was partially anticipated by the work of other scientists. We're talking about the scientific breakthroughs, right? So you're talking about scientific breakthroughs. Well, Mendeleev was not a scientific breakthrough himself. He was just a person. The periodic table was the scientific breakthrough that we're talking about. So you have to say this. You can't say this or it because that's not clear. We don't know what you're talking about because we haven't said the word periodic table since like 3 sentences ago. All right, let's move on to the next question. For example, the French geologist Alexandre Emile Beguer de Chancourtois, long name, is generally credited with discovering periodicity, the existence of recurring trends across elements. So this part is going to be a non-essential part, right? Or not the periodicity part. So it's going to say, is generally credited with discovering periodicity in 1862. Right, that's essentially what we could say, right? We can just get rid of this. I don't know why it keeps doing that. We can just get rid of this part in the middle, in between the dashes, and we have the same thing. right? But we have these dashes here, which mean non-essential elements. So how are we going to approach this? We have a dash here. We can't change that, so we have to have a dash on the other side. We have to have the same on both sides. You have to have either a comma on both sides, a dash on both sides, or a parentheses on both sides to make a non-essential element. Have a dash here. You got to have a dash over here. So we're going to leave it as is with the dash. All right, next question. Let's see. By Mendeleev's own account, de Chancourtois and Newlands were among those foremost in research that led to the discovery of this law. 7. And we have this mathematical relationship named the law of octaves by Newlands would be later defined as the periodic law. So we're talking about, where do we put this? We have the note that similar elements were often related in mass by a multiple of 8. This is what John Newlands discovered. The law of octaves goes with this part. It's discovered by Newlands, so it should go right after sentence 3 right here. So our answer is after sentence 3. Let's move on to the next question. Alright, while not the first scientist to attempt a comprehensive organization of the elements, Mendeleev did publish a paper in 1869 with the first draft of the modern periodic table. In this table, families of elements were arranged horizontally. However, Mendeleev eventually revised this format to the vertical structure found in contemporary chemistry textbooks. Based on the patterns he observed, Mendeleev suggests that the properties of the elements are a reflection of their atomic weight. Also based on these patterns, Mendeleev made concrete predictions about elements that had yet to be discovered. And we're trying to effectively combine the underlined sentences. Alright, so we're trying to make them one sentence. So how are we going to go about doing that? Let's see. So we have Mendeleev made concrete predictions about elements that had yet to be discovered, and before this he even suggested, based on the patterns he observed, that properties of elements are a reflection of their atomic weight. This seems to be a bit ineffective in the way it orders the clauses, right? It says he made concrete predictions about elements yet to be discovered, and before this, he even did, based on that, properties of this. No, we're going to take that one out. All right, let's look at the next one. Based on the patterns he observed, Mendeleev not only suggested that the properties of elements are a reflection of their atomic weight, but he also made concrete predictions about elements that had yet to be discovered. So this says cause and two effects. That's a clean part, right? There's no like doubling back. There's no like there's no adding clauses somewhere. Based on the patterns he observed, he suggested this, and he also made that. Right? That seems to be extremely clear. Let's pick that answer. Let's look at our other answer choices just in case. Mendeleev made concrete predictions based on the patterns he observed about elements that he had yet to be discovered, although he also suggested that the properties of elements are a reflection of their atomic weight. Well, this part is not a conflict with this part, yet it says although. So we can't use although because there's no conflict. So this one is going to be incorrect. Of elements that had yet to be discovered, according to Mendeleev, could be predicted concretely, and he also suggests that the properties of elements are a reflection of their atomic weight based on the patterns he observed. Seems to be a bit haphazard, so that is also incorrect. And our choice is still answer choice B. Alright, let's keep going. For instance, Mendeleev predicted the discovery of two elements analogous to aluminum and silicon. These were later discovered to be gallium and germanium. This predictive power became one of the defining characteristics of the periodic table, and we're trying to keep or delete the sentence. Well, it seems to me that this predictive power, right, that's a main part of everything that's going on. It's an integral part of the periodic table, and it's an integral part of the passage's argument, so we need to keep it, right? Now, which one does it do? It effectively concludes the paragraph by tying the discussion back to the passage's focus on the periodic table. It does do that. It doesn't talk about how it was anticipated by the work of others. It just talks about the periodic table itself and Mendeleev himself. All right, let's move on to the next question. The periodic table proposed by Mendeleev was a culmination of many observations and discoveries. Fortunately, many of his peers were reluctant to accept his ideas. From electronegativity to electron orbitals, the periodic table anticipating many future topics of scientific inquiry. Even today's scientists use the predictive power of the periodic table to generate new hypotheses and design experiments that further expand our understanding of the universe. So the main topic of this paragraph, as we're asked here, is kind of saying that the periodic table is the culmination of these observations, but also spawned entire new fields of studies. Right? So it ended this, but it began this. It was an end and a beginning. Which one do we see here? It's not this part. They're talking about others. Not this part. This doesn't talk about the end or the beginning. This says But like every culmination, this end was also a beginning to those other fields of studies. That is perfectly what we want to say. That is the message that we're trying to get across. Move on to the next question. From electronegativity to electron orbitals, the periodic table anticipating many future topics of scientific inquiry. So what can we see here? It's not anticipating, that's the wrong tense. Seems to be a kind of past tense. So we can say from electronegativity to electron orbitals, the periodic table anticipated many future topics of scientific inquiry. That works out. So our answer is anticipated. But that anticipated or that anticipating are also the wrong tense. And our answer is simply anticipated many future topics of scientific inquiry. That is it for this passage. I hope you liked the video or have found it informative. This is it for the writing informative this passage. We have 3 more passages for the informative section, and I'll see you next time.